Greetings to everyone. So today, me, Sudan, and my teammates So Fuyuan, Li Wenning, and Lai Yongjuan from Truffaut will present about the question assigned to our group on the topic multiple unit. Moving to the description given to this question, Gingerhood is a company that produces ginger supplements. To make the supplement, ginger powder is supplied to an extractor via stream 1. The ginger powder contains 10 weight percentage of the desired target compound C, and the rest are impurities I. Water is pumped to the extractor via stream 2, and this water is the extraction solvent that extracts most of the unwanted impurities. The ratio of stream 1 to stream 2 is 1 to 2. Stream 3 is an intermediate product stream containing 22.47 weight percentage compounds, 10.11 weight percentage I, and 67.42 weight percentage water. The other outlet stream from the extractor, stream 4, contains only I and W. Stream 3 is fed to the evaporator, where 98% of the water that enters the evaporator will be removed to stream 5. And stream 6 is the final desired product stream. 1000 kg of ginger powder is used for each batch of the production. The question asked is draw and label the process flow diagram completely. Question B. Perform the degree of freedom analysis for the overall process and each subunit. Question C. Determine the total mass of stream 6, mass fraction of all compound in stream 6, and percentage of water removed in stream 4 from the total amount fed through stream 2. From the last sentence of the description, we have been given the basis for this question, which is 1000 kilogram ginger powder fit. And from the description, we have known that there are two processes. The first one is extractor, and the second one is evaporator. In the extractor, we have two inputs and two outputs. The first input is the 1000 kilogram of ginger powder, and the second one is water. And the outputs are M2 and M3. And for the evaporator, stream 3 is fed inside the evaporator, and 98% of water from stream 3 is evaporated through stream 5. And the final product is flowed through the stream 6, which contains the M5 kilogram. And in the description, we have given the components for stream 1 and stream 3, and for the other streams we have assigned the unknowns.
After the process flow diagram is drawn and labeled completely, we need to perform the degree of freedom analysis for the overall process and each subunit. For the overall unit A, we found that there are 7 unknowns, which is M1, M3, M4, M5, X1, X2, and X3. 3 material balance, which is C, I, W, and 2 process spec, which the first one is ratio S1 to S2 is 1 to 2. And then the second one is S5 contains 98% of W. So 7 minus 5 equals to 2, so it cannot be solved. For the subunit B, we found that there are 4 unknowns, which is M1, M2, M3, and X1. 3 material balance, which is C, I, W, and 1 process spec, which is ratio S1 to S2 is 1 to 2. So 4 minus 4 equals to 0, so it can be solved. And the last one is subunit C, which we found that there are 5 unknowns, which is M2, M4, M5, X2, and X3. 3 material balance, which is C, I, W, and 1 process spec, which is S5 contains 98% of W. So 5 minus 4 equals to 1, so it cannot be solved.
Now I will present how we determine the total mass of string 6, which our desired product string in kg. From this cell we see the M5 is our unknown to find the total mass of the string 6. In order to find the M5, you should find the M4 and M2 first. Since I will do our DOF analysis, which is 1, we cannot resolve, so we should start from subunit B, which is extractor, to find the M2. So from subunit B, which is extractor, we can find the total mass of string 6. First of all, you should use the equation of process spec, which is the ratio of S1 to S2, in order to find the M2, which is 2000 kg of water. Later on, we should use the compound balance, which is input equal to output, to find the M4, which is the 445.04 kg. Now you can see here that we got the impedance variance and also the total balance to find the M3 and also the X1. These two values should be used for the later on question. Therefore, from this subunit C, we can use the answer that we get from the subunit B, which is from our extractor, to find the total mass. First of all, you should use the equation, which is process spec, which is 98% water absorbed, to find the M4, which is 294.05 kg. Later, we use the total balance equation, which is input equal to output, to find the M5, it is 150.99 kg. So the answer that highlighted is our final unknown should be find, which is our total mass of the string 6.
Okay, yeah, hello everybody. Yeah, so I'll be taking over for part C, second part, and also part C, third part. So we'll start with part C, second part, which is we want to find the mass fraction of all the compounds in stream 6 itself. So we'll take into consideration subunit C, which is the evaporator. So we have few mass balance equation. The first one we will use is C balance, which is input equals to output. And then we have this equation over here to get our X2 value, which is 0.66 kg C per kg. Yeah. So next equation balance we will consider is I balance, which is same input equals to output. And this equation over here, and then we'll find the value of X3, which is 0.30 kg I per kg. Second part, which is the last part of this question, which is percentage of waste removed in stream 4 from the total amount of feed through stream 2. So first and foremost, we will find the total amount of water removed in stream 4 first. So we have this equation 0.67 times 2554.96, and then we have 1711.82 kgs of water removed in stream 4 alone. And then we calculate the percentage of water removed in stream 4 from the total stream 2 feed, which is 2000 kg of water. And then we get 85.59% of water removed in stream 4 from the total amount of feed through stream 2. Yeah, so that's all from our presentation, and thank you guys for listening.